Okay, so we can get started now. Can people in the back hear me? Okay, you can hear me, cool. So yeah, thanks for the introduction. So my name is Raj Subramanian. I'm a developer evangelist for a company called testdriven.io. So a couple of sentences about me and the company. So we, in testdriven.io, we use machine learning for the authoring, maintenance, and execution of automated tests. We mainly do functional testing, end-to-end testing, and UI testing, right? And about me, I speak at conferences, I write on software testing, and also work with the founder of our company to make our tool better for testers like me and you guys, right? So that's pretty much what I do and what my company is about. So we can get started with the agenda for today. So I'm going to talk about, first thing is, what are the current challenges with software testing and how AI can help to solve those challenges, right? So I'm going to talk about challenges, how AI can solve those current challenges, and just to ensure everyone is on the same page when I use terminologies in AI. So I'm going to set some context and give some basics on what AI actually means so that everyone after this presentation can talk about AI, right? So that's the goal. And finally, I was going to talk about what's the future of AI. So first, let's set some context. To understand the challenges of software testing, we want to also take a step back and understand how software testing has evolved in the past 30 years, right? So in one end of the spectrum, over here in the 1980s and 1990s, right? Testing was predominantly manual testing, where pretty much there was not enough skilled testers and everything was manual, right? And the software development was also pretty much waterfall, where development teams will work for, say, 6 months on an application, right? And then finally the QAs would get their hands on the application, and then they find bugs. What happens next? You go back, then you have to restructure what you did. There's a wastage of cost, time, and effort, right? So that's how 1980s and 1990s were. Then we have the 1990 and 2003 period, right? So we had bulky automation tools. One second, I'm going to stand here because I usually walk a little bit. This is kind of restricting for me. So anyway, okay, this is really good now. So in the 1990s and 2003, we had bulky automation tools, right? So these tools which came up had good functionalities to help manual testers, to help in manual testing, but they were really primitive in terms of the features they offer. And also, if you wanted to do something extra apart from what the tool already has, we couldn't do it. We were restricted by the tool, right? So that was 1990s and 2003. And at the same time, we started experimenting with different development approaches like Scrum, XP, RAD, which is Rapid Application Development, right? So that's what happened in the 1990s, 2003 period. Then in 2003 to 2010, in that time frame, we saw more robust automation tools coming up. And then there was the birth of open source frameworks, right? So there was this like-minded people in the community who wanted to share their knowledge with other people, but also wanted to contribute to improving software testing. So for example, Selenium, it started in the 2003-2010 time frame, right? And it encouraged collaboration and other testers in the community to help out in solving common problems in software testing. And then at the same time, Scrum, XP, Kanban, and all the agile approaches became a thing, right? It became a normal thing in the software development life cycle. And then from 2010 to current time period, it's all about scale, right? Everything is about scale. So what do I mean by that? So what we want is we want to run tests fast. We want to find bugs fast and want to release faster, right? So that's what I'm talking about when I talk about scale. And because of that, two things actually came up in this time period. One was crowd testing, where companies were giving their application to testers outside the organization so that they can actually use the application, give them feedback before the end user actually gets their hands on it, right? Crowd testing. That's one thing which came up in this time period. And then cloud testing. So there was a need for faster processing, server infrastructure, running tests in parallel, and and then you also needed to run tests faster, right? So that's what I mean when I say scale. And then we had DevOps, continuous testing, CI/CD, which also has become relevant right now. And now we're going to talk about the future, which is autonomous testing, right? So how to make your test simpler, smarter, faster, and stable. So that's what we're going to talk about today, the future of how AI is going to influence testing. So I just wanted to set some context, right, to understand how we have evolved and why AI is going to be useful. So let's quickly talk about the current challenges in software testing. So we recently did a survey on how frequent people release software, and this is what we found. So we have 13% of the people who said they keep testing the product until they think it's really good quality, right? So they end up releasing the software once in 6 months or once in a year, right? And then you have majority of the people who have extended testing phases where they do rigorous testing for a long time period, and because of that, they release on software only once in 6 months. And then finally, on the other end of the spectrum, we have only 2% of the people who actually release software every minute of every day, right? And now if you want to visualize the survey, this is how it's going to look. We have the laggards in one end of the spectrum, and then you have the innovators who release multiple times a day, right? And in each phase, you have different challenges. And these are important to know because I'm going to talk about how AI is going to help to solve these challenges, right? So, okay. So the first challenge is skill set. So people who are in this phase, remember from that survey, we had about 13% people who release their software needs once in 6 months or more. So they have this challenge of skill set where finding skilled testers is expensive, time consuming, and because of that, and they don't have any automation, so because of that, they release really late. Then we have this challenge of authoring. What do I mean by that? So say authoring means writing tests, right? Authoring a test. And people in this phase, what they do is they write tests, but they do not pay attention to the important concepts of automation like reusability, how to make reusable components, how to parameterize your tests, right? If you want to test a lot of user combinations, username password combination, and also they don't think about having adequate element weights between your automation scripts, right? So that the tests do not fail. So that's the challenge of authoring in this phase. And then we have the next challenge of initial state. So what do I mean by that? Let's take this example, right? So this Amazon, and say you're writing a test to add an item to the cart. So you're the tester, you write the test to add to a cart, and wow, that's awesome. We already added a item in the cart. What happens if you run the same test again? It's going to add 2 items in the cart, 3 items in the cart, 4 items in the cart. The reason is you want people forget to reset the application to its initial state, right? And people in this phase, the early majority, late majority, in the middle, they suffer with that where they don't pay attention to the initial states of the app, and because of that, it affects release cycle. And then finally, we have maintenance and scale, which are the biggest problems with software testing and test automation in general, right? So now, say you're a tester and you have 500 tests running, and He comes in the next day, and you know what the challenge is going to be. Out of his 250 tests fail, there's a lot of bugs, right? And then he's going to spend so much time trying to fix those tests, right? A recent survey said 30% of the of testers' effort just goes in maintaining the test, right? That's crazy, the amount of time we as testers spend on maintaining the test, right? So I talked about a maintenance piece, and I also talked about the scaling piece before. So these are the 5 current challenges which exist, even though software testing has evolved from 1980s, right? We still have the same set of challenges, and AI can help to solve this. So before we get into how AI can help to solve these challenges, right, I wanted to explain some basic concepts of AI so that everyone is on the same page when I use different terminologies. So all the way at the top, the big circle is artificial intelligence, right? So what is artificial intelligence? It's the field of study to create intelligent machines which can work, think, and react like human beings. So that is artificial intelligence. Then under that, you have machine learning. So machine learning evolved from the field of study of pattern recognition and computational theory. What computational theory means is study of learning algorithms is called computational theory, right? So machine learning is basically the ability to make computers learn without explicitly programming it. So that is machine learning. So you have AI, and then you have machine learning, which is a subset of AI, and then you have deep learning, right? So just like deep learning, you have various subsets under machine learning. You have Bayesian networks, you have inductive logical programming, and deep learning is another branch of machine learning. And deep learning is important to know because that's what we are using everywhere right now. So what is deep learning? Deep learning is based on neural networks. It mimics the way neurons work in the human body, right? So in the human body, we have so many neurons. Each neuron starts interacting with other neurons and then starts creating a whole network, and they start reacting, responding based on what other neurons are doing, right? So that's where the word neural network comes in. It's part of deep learning. So deep learning, neural networks, they pretty much mean the same thing. So whenever you hear these two terminologies, right? So it's pretty much synonymous, and it's based on the human neural system. So one good example for deep learning would be, say, for example, you want to find different relations when you, between the size of a house and the price of a house, right? That I'm just taking a very simple example. So what you start doing is you give different input-output combination, which is called a training set, right? So whenever you hear the word training set in AI, don't get scared. It's just input-output combinations to train the algorithm. So in this case, you're going to give the size of the house and the price of the house and see what relations you can get. Then you give the number of bedrooms and the price, and then the AI probably can find a relation called family size. So based on these parameters, it makes a relationship called family size. Then you give zip code and the price, and then probably the AI would determine how walkable the place is, right? And then you may give the wealth and the price, and then the AI could probably predict the school quality. So all these relationship in turn then goes and affects the price, right? So AI is a black box. So you just give a set of inputs and outputs and then try to get all the relationships. So whatever you see here is what the AI does, right? So it keeps learning based on the input and output combinations you give. So this is how deep learning works, right? And that's what people are using in most of the technologies right now.
Alvin is a system of artificial neural networks that learns to steer by watching a person drive. Alvin is designed to control the NavLab 2, a modified Army Humvee equipped with sensors, computers, and actuators for autonomous navigation experiments. The initial step in configuring Alvin is training a network to steer. During training, a person drives the vehicle while Alvin watches. Once every 2 seconds, Alvin digitizes a video image of the road ahead and records the person's steering direction. This training image is reduced in resolution to 30 by 32 pixels and provided as input to Alvin's 3-layered network. Using the backpropagation learning algorithm, Alvin is trained to output the same steering direction as the human driver for that image. Initially, the network steering response is random. After about 2 minutes of training, the network learns to accurately imitate the steering reactions of the human driver. This same training procedure is repeated for other road types. After the networks have been trained, the operator pushes the run switch and Alvin begins driving. 12 times per second, Alvin digitizes an image and feeds it to its neural networks. Each network, running in parallel, produces a steering direction and a measure of its confidence in its response. The steering direction from the most confident network, in this case the network trained for the 1-lane road, is used to control the vehicle. Suddenly, an intersection appears ahead of the vehicle. As the vehicle approaches the intersection, the confidence of the 1-lane network decreases. As it crosses the intersection and the 2-lane road ahead comes into view, the confidence of the 2-lane network rises. When its confidence rises, the 2-lane network is selected to steer, safely guiding the vehicle into its lane on the 2-lane road.
So can anyone guess when this video was published? 95, that's a really good guess. Any other guesses? 91, really good guess, right? So you were pretty close. So this video was released in 1992. So autonomous cars, we are hearing about it only 3 or 4 years ago, but the research was already done, and this video was posted by Stanford University. And this is a real example of how you're training a neural network. In this case, it was Alvin, the autonomous car. You're driving and feeding it data, and then it started driving on its own, right? So I was just giving you an example. So that was the basics of AI, and now at least you have some idea on what each terminology means and how they actually train it. So next one I wanted to do was the main thing of how AI can solve these current challenges, which I was talking about, right? So at Testim, in our company, so there are many companies using now AI to solve different problems of software testing. At Testim, we are trying to make tests faster, simple, smarter, and stable, and we are tackling the main problem of maintenance and scale, right? This is a really good diagram from a friend of mine named Jason Alvin. He has another AI testing company called Testa AI. They're trying to solve the problem of getting monitoring information about your application, and if you see over here, over time, the complexity of software keeps increasing, right? So in terms of test coverage, it's linear, but the complexity keeps increasing exponentially. And then there's this coverage gap. And that's what we could actually solve by using AI, right? So something just to keep in mind. So next one, I wanted to talk about the future of AI and some of these things which we are already using right now in our software, but I know other people are doing other stuff as well. But I wanted to show you some things which people are using AI right now for software testing. So one is autonomous testing, where the AI starts learning by observation. So it starts observing how end user uses the app, how the developer is using the app, how the QA is using the app, right? So based on that, it can start aggregating user flows. So it's going to recognize all these actions and going to create user flows. And then it's going to feed it into the system or test tool, whichever you're using. And then it can generate test scenarios and test cases or test flows for you, right? And because of this, there's a lot of advantages. One is that it helps QA to get good test coverage, and you can create more user scenarios within a short span of time, right? Just by doing this. And then we are also doing a risk-based approach in terms of everything is data-driven. All the decisions are made based on data, right? And now QA is a science. It's no more just, just doing something for the sake of doing it. Now it's a science with AI implemented in it, right? And another biggest feature of doing autonomous testing is the self-healing mechanism. So what do I mean by self-healing? So what the AI could do is it can proactively detect problems before they even occur, right? So you're already ahead of the game right now because it just detects problems before it happens and keeps fixing it in the background, and you don't even have to be concerned about it. So it saves a lot of time then finding a bug and then trying to fix it, right? So that is the autonomous testing piece, the self-healing piece, which we are currently working on, and I know other companies are working on as well, right? So those are some things which are relevant right now. So the next thing was, we have heard of test-driven development, but with AI, you can do UI-based test-driven development. So what do I mean by that? So usually when software development, you have these markups that the designers give you and markups are screenshots, right, on what feature they want. And then what the developer does is based on the markup starts coding and develops the feature, and then the tester starts testing it. But instead, we could do this, and we're trying to, and currently working on this, where you have the markups. Oh, crap. Oh yeah, we have the markups, right? And then what happens is based on the markups, the developer starts coding it, but at the same time, the AI can recognize the screenshots and start creating user flows in our test tool, right? And then once you run the test, of course, you're going to get a red failure because the feature has not been implemented yet. But once the developer finishes implementing the feature, you can run the same test based on the markups, which were created based on the markups, and then you can make sure it's a green. If not, then you have figured out an issue, right? So UI-based test-driven development is something you can do using AI as well. And then finally, we have automatic response. So the point is, you have these UI tests, which has a lot of server client requests going on. So what happens is, say you have a login button, you have to click on a login button. So the request goes to the server, and then you get a response, right? And it's really time consuming. With AI, what we could do is we can record all the server response and the responses actually, and then whenever you make a request, the thing doesn't need to go to the server. You record all the responses and you can just keep sending it to the test. So in that way, the tests are much faster. right? So those are some of the applications of how AI is going to be used in the future, and some of which we are also trying to work on currently. And then finally, how Testim is paving the way for the future, right? So we have, so autonomous testing can help eliminate the quality velocity dilemma. So what do we mean by that? So in terms of quality, it makes it easy for the QAs to maximize user coverage, right? And then we are taking a risk-based approach based on data, and then we are preventing bugs proactively instead of fixing them and waiting for it to happen, right? In that way, it helps quality. In terms of velocity, you can create more scenarios in just short period of time, because using AI, it's going to monitor different actions, user interactions, and then it's going to create the AI, right? And then you can deploy resources much more effectively to create tests. And finally, you can also do root cause analysis really quickly, because the AI is going to tell you these are some issues happening, and it helps to pinpoint your problem, right? And before I finish, I forgot to mention one thing though. So when I was talking about the basics of AI, I forgot to mention three things. So there are three types of machine learning algorithms which are currently present, right? First is called supervised learning. Supervised learning means you give the right input-output combination and then make the algorithm learn. Like what the examples I showed you, that's an example of supervised learning. For example, how many of you have Netflix and Hulu accounts? Okay, Netflix. So you have that feature where it recommends movies for you based on what movies you watch. That is the AI or machine learning underneath the app, which is actually doing that, and it recommends movies based on your user interaction. So that's an example of supervised learning. And then they have apps where you can give an email and then find out which is spam. You can give audio, get text from it. So those are all examples of supervised learning. And then you have unsupervised learning. The unsupervised learning is just giving a bunch of data and trying to see what relationship you can get, right? And examples for that would be, you can give an image and create a 3D model out of it. And then market segmentation. A lot of companies want to do market segmentation, so that's when you use unsupervised learning. Then finally, you have what is called reinforced learning. Reinforced learning is the concept of rewarding good and bad behavior. So you'll give a bunch of inputs to the computer, it'll output something, you'll say good. Then it'll understand, okay, that's a good thing to do. But if it outputs something wrong, you'll say bad. It's like training a dog, right? But the thing which you're going to hear a lot is supervised learning. Autonomous cars, everything are examples of supervised learning, where you give proper training set, the input-output combination, and then make the algorithms learn, right? So that is something you want to keep in mind. I forgot to mention that when I was covering the basics of AI. But anyways, so those are all the things you could do with AI, and why I showed you also how the AI can actually do things for you and help you out. And we can solve the problem of skill set, authoring, maintenance, and scale using AI as well. So that is pretty much what I wanted to say. And if you, I think in a day I'm going to post a summary of whatever I talked about with all the pictures and everything. So you can go to blog.testim.io and then you can see the summary. And also, if you are more interested in how the AI works in our tool, you can actually go to softwaretestinghelp.com and just search for Testim. Then you'll find an article where we talk about how the AI is working underneath the hood. And if you have any other questions, of course, you can email me at raj@testim.io as well. So yeah, I try to cover everything as fast as possible because we were already late for lunch. So thanks for sticking around, and that's a wrap. Thank you.